let's get started. Well, I'd like to welcome everyone to this DCS webinar series. Our hot topic today is why net zero focused smart enterprises deploy hyperfast optical and wireless technologies. So I'm the host, I'm Gunter Rice. I'm the Chief Marketing Officer and Head of Business Development at DCS. And I have really a distinguished panel here with me today. Right next to me here, you will hear after me, after a short introduction of who is really DCS, some of my perspectives about why passive optical LAN is actually this next great technology, which is not really brand new, but it has seen a lot of uptake over the last couple of years, and then more to come. So Andy is a SE in DCS here in the UK, and he's one of the practitioners, having worked with the technology for more than 12 years. We have a guest speaker, two guest speakers. We have Kevin Robinson, who is with Ahimanu. He is one of the, I would say, the practitioners longest, working not just with some of the Ethernet technologies back in the 90s, but being a practitioner and an advocate of fiber LAN and passive optical LAN, and he's a digital technology design consultant. And then we have, last but not least, we have Ian Irving from Connectix, and he's the head of sales at the company that works in structured cabling, Cat5 cabling, fiber optic cabling for the last more than 20 to 30 years. So really excited about the panel, and everybody will get an opportunity to share their perspectives and the pros and cons. And it seems like a lot more pros than cons for this hot technology that so many enterprises are gravitating to. So very quick, DCS at a glance. We're a company with, more than 20, this year is 25 years anniversary. We're headquartered in Dallas, Texas, publicly traded. Our vision is really to deliver an open and automated broadband network. And we have a portfolio that is really known for being a developer, disruptor in many ways on the network edge, connectivity, and cloud software solutions to enable ultimately gigabit broadband anywhere or everywhere. And of course, as you see, we have a large number of customers, particularly in the service provider space, but we have a really relatively large number also of customers that are in the smart enterprise environment. And so what are some of the pioneers and early adopters in various verticals that really gravitated very quickly to this, what we call fiber LAN at DCS, but passive optical LAN environment? And hospitalities, a lot of hotels have started over the last years already to implement fiber LAN. And we will hear more from our panelists why they chose this technology. We see it in the government space. A lot of new office buildings have started to not just look at the passive optical LAN technology, but start to implement it in the education space, healthcare, particularly hospitals, mission critical networks. CIOs are starting to realize, what can this technology do for me? And it's really scaling because we are using it today in the service provider space to connect millions and millions of subscribers. And here in the enterprise, we are talking about 2,000, 5,000, 10,000, 50,000, 100,000 endpoints. Look at stadiums. I'll talk a little bit more about that. In the US, you have stadiums, well, in the UK, we have stadiums as well in the size of 50,000, 70,000, 80,000, sometimes 100,000 endpoints. And devices that just need to be connected. We see it mining, camps, military, and all kind of in different industries that are now joining that momentum what we see in the passive optical land space. Here, just a quick example. Again, these are two examples from the US, but they show the gravity. They show the impact that this passive optical LAN technology has. And just imagine when you're in a stadium, you see nowadays all these this LEDs or this monitors everywhere, where you see the menus when you purchase whatever you purchase in the stadium. You have again concession stands. You have all the security, CCTV cameras. You have again, we walk in there with our mobile devices, and everybody wants to be connected all the time. And for that reason, it is just from many different reasons, and I'll go through that, and my panelists will go into more detail why some of the largest stadiums have started to deploy this type of fiber LAN or passive optical LAN technology. And so in summary, some of the highlights are you save a ton of space. For some, it might be 70% reduction in floor space. For others, it's up to 90%. That is a dramatic reduction. The decreased power, everybody is obviously concerned about power consumption. We see it with the big operators, and we see it with the smart enterprises. Everybody is looking for how can we reduce power, because power in general prices have gone up. Is it more secure? Well, people can ask the question, is fiber more secure than copper? Well, you will hear from the practitioners directly over the next few minutes. Lifespan, of course, we know that fiber has a much longer lifespan than copper, and it's the same. Is it future-proof? And how much? What's the speed we can transport now over fiber versus copper? To be honest, it's not even close. So fiber is dominating. And especially we see a lot of development, a lot of new buildings, a lot of construction in the UK. And people are looking for a more green technology. Net zero carbon emission goals have to be met. LEED goals have to be met. And so, you know, there are a lot of reasons. And of course, in the end, everybody will say, hey, what does that mean for me from a CapEx and OpEx perspective? What's my total cost of ownership analysis? And I think for everybody here in the audience, you just have to take a look at it. You really have to take a look at it and see, you know, analyze all the different aspects we are bringing up here, and then just test it out if this is something which you should really, for your next project, consider. And with that, I'd like to hand over to Andy Butler, who has been working with the technology for more than 12 years. So Andy, and I'll just tell me when I shall switch to the next slide. Over to you.
Okay, thanks, Gunter. Hi guys, yes, so I'm Andy Butler. I am an SE at DZS. I've been around for just over 6 years now. But as Gunter said, I worked with fiber LAN or pole technology for almost 12 years now. And before that was actually a Cisco engineer for 17 years. So I can sort of come at it from both sides. What I'm going to do for you really is just give, I can see the names of the people that are attending, and I realize that there's quite a few people in there that I know. So, but we wanted to just give a bit of an overview about fiber LAN technology, sort of what it is and how it works. Just a couple of slides on that, just as a refresher, really, and not too technical. And then I'll go over a couple of different technical aspects, and then maybe a couple of different use cases. So just to briefly explain, what we have here on the left side of the screen is how we do a traditional network using traditional Ethernet switches, layer 2, layer 3 switches, and a core. So at the top of that, we have the router, and that's the smart part of the network where all of the real sort of the traffic decisions are made, if you like. Then we have what we would call a distribution layer or an aggregation layer where we see campus aggregation and building aggregation. And then we have what we call the access layer, which are the switches that you see in the IDF rooms, the rooms on each floor, where all the horizontal cabling is connected to that goes to your desk. That's how we do a traditional network. We've done it like that for probably the last 25 years. It's a model Cisco say they invented, and it just works. What we're actually doing here with passive optical LAN is we're taking away that distribution layer and the access layer. We're putting in a passive network, so fiber, single mode fiber, splitters, and we're taking the access ports all the way as close to the end device as we possibly can. Now, where you put these splitters, where you put this fiber cable in, it really doesn't matter. They can go in a closet, in a ceiling space. They're completely passive. They don't require any power. You could literally concrete them into the floor if you wanted to, but we don't usually do that. And what it now gives us is just one central control unit that's the OLT, and the ONTs, they can also be pretty much wherever you want. They can be under desks, they can be in false floors, they can be on walls. We have lots of different styles of ONTs, some that look like just a standard faceplate that might go in a dado rail, 4 ports, 8 ports, 2 ports, 1 port, all of this is possible. So that's pretty much how a traditional LAN differs. So just a bit about how it works. Brilliant anticipation there, Gunter. Thank you. So just a bit about how it actually works. We've got the OLT. This is connected to your core, just like a traditional Ethernet switch. At that point, we take Ethernet traffic in and we put it onto the GPON network. It goes on to the single mode fiber, goes onto the passive part of the network, if you like, and kind of goes out like a broadcast to all of the ONTs. Now, the standard that we know that's been around for a really long time is GPON. And GPON, for every port, one splitter, by the way, is one GPON port. And for every one of those, what we do is it's kind of like a shared bandwidth between all the ONTs on that splitter. We share 2.4 gigabits in the downstream direction and 1.2 gigabits in the upstream direction. That's per GPON port, so per splitter, generally per 32 or 64 ONTs. Now, the new standard is XGS-PON, which stands for 10 GPON synchronous. So it's 10 in the upstream direction and 10 gigabits in the downstream direction. Actually, it's quite a funny thing because the 10 GPON has been driven a lot by the enterprise, but the enterprise uses a lot less bandwidth than the service providers or the home user uses because people are not watching, high definition movies sat at their desk like we are at home. So that's GPON and XGS-PON. These are available now, and these coexist on the same piece of fiber. So you may have some users in your enterprise that are just on GPON, sharing 2.4 gigs, and you may have some users on the same piece of fiber on the same splitter that are using XGS-PON, and these can coexist because the data flows on different wavelengths. The next one that we see there at the bottom is 50 gig PON. So this is going to be a shared network of 50 gigs in every direction per splitter. We already have this working now. We already have but of course the market isn't ready for this yet. Not even the service provider market is quite ready for this yet, but that's going to be the next step up. That was in a nutshell. It's obviously a much bigger topic than just that, but hopefully it's given you a little bit of an oversight of what we've got. So the one thing I want to get across to you today really is that what GPON and passive optical networking allows you to do is to tear up the rule book. We have done for the longest time, we have used the 100-meter rule. With some people designing their networks based on no network point being any further away than 90 meters to the nearest switch, and then of course using fiber between the switches. This will allow us to completely rip that up because we can go 20 kilometers between the OLT and the ONT. Now, a lot of people don't have 20-kilometer buildings, but there are certainly a lot of applications where things are spread out in a very big way over the campus. And this will allow us to really design the network very, very differently. What it actually gives us as well is a fast and intelligent network that takes fiber all the way to the edge. I think for the longest time, probably 20, 25 years ago, we were trying to find ways of getting fiber all the way to the desk or all the way to the endpoint. But of course, a computer or a phone or anything else doesn't have a fiber connection. So this actually does allow us to do that. And for that interest, we work with a lot, for that reason, sorry, we work with a lot of sort of the military organizations because fiber, of course, is much more secure. Using fiber means that you've got a tiny network footprint. Something that Kevin will go into a little bit later is the differences between using copper cables and fiber cable. It gives us a really tiny footprint. If you were going from a switch to a particular wing on a building, you would need to have one network cable for every single point. So if you've got 120 endpoints there, you could put all of those onto, you would need one cable for every single edge point. With this, what you could do is you could put the splitter as close to the users as possible and just run a single cable. And you could have 128 if we're using a 1x32 split rule. You could have 128 network points just with one long piece of fiber. So it allows you to get rid of all of the containment and such that you need and all of that cabling. One of the things that we've found, if people are doing a network refresh, that is a massive stumbling block because we've had a lot of opportunities and projects that we've worked on where they need to add more network points to rooms or to buildings. And it's very difficult now, as you probably know. Cat5, Cat6, Cat6e cabling is very big. Next, there'll be Cat7 and Cat8, and this cabling is very big and has bend restrictions and things like that. It will allow you to cut down on all of the disruption of removing all of that cable, putting bigger cables in by simply sending very small pieces of fiber to the locations. Also solve some unusual historic problems. I'll go into that in a moment and give some premium space back. These are kind of just a couple of benefits. Thanks, Gunter. We'll go on to the next slide. So yeah, smart networks for smart buildings. One of the things that GPON does is it has something called dynamic bandwidth allocation. And this will allow the network to really intelligently and really out of the box give the bandwidth to wherever it needs to go. So if one user's needs a lot of bandwidth because they need to upload or download big files, for instance, a pathology department in a hospital, these places tend to do that at night. They wait until the nighttime until the network is quiet so that they can send these files across because they're very, very big. Well, they won't need to do that with GPON or XGS-PON network because it can dynamically allocate them and burst up to the sort of speeds that they need, taking the bandwidth from where it's not being used. So dynamic bandwidth allocation is really good, but the big difference between this network and a traditional network is it can give you a minimum bandwidth that you might need. Now, we can obviously always set port speeds on a traditional switch, but what we can't do is just say, this is your bandwidth and this can never be touched by anybody else. And the example I use here is a CCTV camera, because the CCTV camera, the traffic generally goes in the other direction. It goes from the edge to the center, whereas in a traditional network, most of the download speed is usually needed more. So what we can do with CCTV, for instance, is we can say, this is your 6 meg of bandwidth and nobody can ever touch it. So if there's ever a denial of service attack on the network, if there's ever a if there's ever a packet storm on the network, that bandwidth will not get knocked out because it's for that port. It uses time slots and it says, these are your time slots and nobody can ever take them away. And we simply cannot do that on a traditional network. Okay, Gunter, thank you.
You're welcome.
So, I realize I'm flying through this, but I'm not sure how we're
No,
doing.
this is good. This is good. It's
Good,
very,
good.
it's
Uh,
exciting.
so yeah, the everything is managed centrally on this network as well. We're of course talking about a lot more devices here, and with this system, the OLT controls all of the devices on the ONT. So every port, every ONT that's on that port, every user port is under central control, right down to how much power over Ethernet it might need, what VLANs it might need, how much bandwidth it might need. This is all centrally controlled. And GPON is what we call a stateful protocol. So there has to be a really close relationship between the ONT and the OLT, because the OLT actually tells the ONT when it can talk, when it can send its packets there. So in theory, if you're watching this screen here, you would know if there was a problem on that network before the user knew that he couldn't get onto the network, because it would you could set it to alarm to say this ONT has now lost its fiber and this ONT has now lost its power, whatever it might be. So you could send those alarms elsewhere. So it's a really easy network to troubleshoot. You can almost instantly see if the problem is on your network. As I mentioned, I was a Cisco engineer, and I can't count the times I've been along with my little blue cable to a data center somewhere to plug into it to find out what's going wrong with the port. Is the port flapping? Is it up? Is it down? Whatever. We can see that all centrally from here. And the system even gives you why it might alarm. So if it's lost power, for instance, it sends what's called a dying gasp. So you know that the power's gone off of that. If the fiber's been cut, it sends what's called a loss of signal. So you know that the fiber has got a problem. So for troubleshooting, really, really good. Also, on the security side of things, we often get asked about ports. You may have an ONT in a lamppost 2 kilometers away at the end of a car park, if we're talking about maybe something like a shopping mall or and such. People worry that people can go along there with a computer and plug a port into that ONT, plug a cable into the port on the ONT, and actually see if they can get any data. Well, they simply can't. If you've not configured that port, you won't even see a broadcast, which again isn't like traditional Ethernet network. You will see nothing at all. The port is just dead unless you've configured it. And of course, the big one, do the ONTs hold any data if they get stolen? This is particularly relevant for maybe if the ONT is in a public place and somebody decides to steal it, it's completely useless. It doesn't hold any information at all. No usernames, no passwords, no IP addresses, nothing at all. It's completely a slave to the OLT. Thanks, Gunter.
Absolutely.
So why fiber is the future? There's no doubt about that. We can see every single one of us now is bombarded with fiber to the home and super fast fiber, and there's a reason for it. The longevity, the high speed. We don't know the amount of data that the fiber can give you. We know that it's completely future proof. It can last for 25 or 30 years without being touched. It's very tough now. There's no doubt that high speed services should be delivered over fiber. So why not bring that into the enterprise? Why not bring the networks that we have all over the world now for high speed services? Why not bring those into the enterprise? There's no reason not to, because the truth is there's no downside to the user. All IP devices are supported. Sorry, Gunter, just back, not quite there yet.
Uh, I'll get
It's
there.
yeah,
I'll get there.
thank you. Yeah, all IP devices are supported. IP phones, analog phones, desktop computers, cameras, video cameras, TVs. As Gunter was saying, we have a stadium where there are 3,000 screens in this, including a big 360-degree screen. So all of these services can be delivered. We do a lot of different types of ONTs. 8-port ones, 4-port ones, PoE ones, Wi-Fi ones, industrialized ones, outdoor ones, 24-port ones. We have them all. But the point is there is no difference to the user. All that they see is an Ethernet port with an RJ45 cable that they plug into their phone or their PC or whatever. There is no difference, and it's a 1 gig port or a 10 gig port now, giving them exactly the same connectivity that they would get from a traditional switch. And lastly, I suppose that I've just said it. There's only advantages. The user experience is better because it's faster. Management is easier. The TCO, the total cost of ownership, is lower, and it makes your network future-proof. Now we can go, Gunter. Thank you. So
you're getting the timing right.
yeah. So what? Of course, I've just given you a quick whistle-stop tour of the network there, but it isn't just about technology. It can actually give you some other advantages that kind of lead into what Kevin's going to tell you about. We have a project currently ongoing, and this place is 130 years old. They had 20 years ago, they put two Ethernet ports into each room, and one was for a phone, an IP phone, and one of them was for a Wi-Fi access point. They now need 8 in the room because the minibar has one, the door control has one, the air conditioning has one. So they now need 8 in this room. But you can imagine a 130-year-old hotel is going to be hard to get another 6 cables through all of those really big, thick walls to actually give them the other 6 ports. But there's another point to it. There are actually on each wing of this hotel, there's a room on each floor. So 2 rooms on each floor that used to be a bedroom and is now a data center. It's got racks in there with switches, with horizontal cabling going everywhere. If we take everything back to the central site, we run fiber to locations near those rooms, put the splitters into the ceiling or into the technical space where they have the fuse boxes and such, then run single pieces of fiber to each room, we actually give them those rooms back. So that's 10 rooms. It's 8 or 10 rooms. I can't quite remember. We've got 10 here. It's 10 rooms that we can actually give them back, giving them an extra stream of revenue. So it doesn't just solve technical problems for them. It doesn't just solve cabling problems for them, but it actually increases the revenue for them. So it's really interesting that. Yeah, this is another one actually. This is a retailer that we're working with. It's very well known in the UK, but I can't tell you who it is. These are a really old retailer with stores on just about every high street. The high street stores, which are about 92% of their stores, are over 100 years old. And 3 times a year, they have to move the stores around. As you'll know, they do. So you go in one day to try and find something, the next day that it's moved. So they move them around to keep it refreshed, but they work to a 70-meter rule. So their point of sale material can never be more than 70 meters away from the switch. And the reason they do that is because every time they move these point of sale, the tills and the TVs and such, they have to get an asbestos specialist company in to move the cables in the ceiling spaces because these are very, very old. And this is costing them on average £200,000 per store per year to do this. 3 times a year they have to do this. So it's £200,000 per store per year. So what they're looking at actually doing here is just putting enough fiber in to the store so that they can put it wherever they want. The fiber will just go in like blown fiber, it will just go within a small tube, and it can be pulled backwards and forwards on a spool for whatever distance they need. So they can now put their point of sale materials anywhere and everywhere just by pulling the fiber backwards and forwards through the tubes, and they don't have to have the asbestos company in every 3 months to actually move cables. So again, I only can't try and highlight this because it's just that it isn't just a technologically better network, but it can actually solve problems for the customer as well. And that's, if you're new to this, that's where you're going to find your successes right now. Where does fiber solve the problem for it? if it's a brand new building, we can now build the building for the people and not for the network. But if it's not a brand new building, what problems does it solve? Thanks, Gunter.
Brilliant. Absolutely brilliant. Thank you so much, Andy.
My pleasure.
Again, what I really enjoyed, when I met you the first time, it's not just the passion you have about passive optical LAN technology, but also the experience you have in it to deploy it, to understand, the general. And you said it correctly. What problems is the technology solving, and that's ultimately, that should be the number one priority when you make these decisions. In terms of, really, it's not always just, it's capex, it's the space reduction, it's lower power consumption, all these things. But as you showed clearly in this scenario, it really requires a look into the specific scenario, the use case, and why this technology is just a better fit than traditional LAN technology. And I know we will not change the entire world from the traditional LAN technology to passive optical networking technology from one day to the other, but it just shows why this technology is such a great fit for so many use cases of the smart enterprise evolution.
Yeah, for sure. For sure.
With that, and I know you have a chance to address some of the questions from the audience, as well as some of my questions, which I generally get bombarded with as well. But so thank you for now, and I'm going to hand over now to Kevin Robinson, another practitioner who has a lot to share, a lot of insights to share. So over to you, Kevin.
Thanks, Gunter. I'm more an evangelist than I am a practitioner. So much to follow on from Andy. He's got loads of things there. I could go off and spend hours talking about this. Like Andy, I've been a Cisco man myself. I used to be a Cisco network professional and Cisco design professional back in the day. I've actually been in networking, I've been in IT for over 30 years, and I can even go back to when I was first cutting my teeth on things called Ethernet hubs. There were no switches when I started. That's a little story of a little company called Calpana invented the first switch, and it was then bought out by Cisco, and everything changed thereafter. But I've done everything in networking, and I've crawled through the floor spaces and the roofing spaces and ceiling spaces and upside down walls. And I've installed all the network switches, and I've done all the network design, and I've run IT teams and network infrastructures. And I encountered POLAN back in 2017, and I was immediately skeptical. This couldn't be that, this is too good to be true. And the title here, the pros and cons, because there aren't any cons. The pros and cons, I should say, because there aren't any cons, is just that. I spent a couple of years trying to find the cons, and they really just don't exist. So we're going to talk about a few things here. Some of this is going to be repeating some of the things that Andy said. We'll dive into a couple of things, a bit more detail maybe, and talk about them. So go to the next slide, please. So let's talk about a couple of things. We're going to talk about total cost of ownership, and that's broken up into two aspects, capex and opex. And let's just get the first one, which is the capex side of things. And what we're talking about when Andy's got his diagram about collapsing those network edge switches into the core, into your main equipment room, what you might call it a server room or a data center. This is what PON is effectively doing. And incidentally, you can call it PON, you can call it POL, you can call it POLAN. They're all pretty much rose by any other name. What you're doing is you're collapsing all those edge switches. So you've got loads and loads of network switches, 24, 48 port switches out in little IT hub rooms or secondary equipment rooms, whatever. You're going to be collapsing those down into your main computer room, wherever that is. I call them main equipment rooms, but everybody has a different name for them. And what that means is you no longer need those spaces. And if you're building a new building and you've got an IT hub room that's averaging, say, 10 square meters, you're getting rid of that and you're replacing it with what we see on the right-hand side of this image here, which is basically a small cabinet. smaller probably than your good old-fashioned fire hose cabinet that you used to see around in buildings. That's the difference. You're going from 10 of average of 10 square meters with racks in them down to this little cabinet. Now, if you're building a building from start, each square meter of space in a building costs on average around about £5,000. So if you can imagine that a IT hub room at 10 square meters is going to cost you £50,000 of capital build cost, and you've got 10 of those, you've just wiped out $500,000 in your capital build cost. And I'm involved in designing hospitals, and we talk about numbers in more in the 50 or 100 IT hub rooms. So we're talking millions of savings in just capital build of your building. Or you are releasing that space to be used for something else that can be more about your business earning revenue. Next CapEx aspect that you get out of this is, look at it, you no longer have to have a rack. You don't have to have a rack. You don't have to have any air conditioning, any environmental controls in there. You don't have to have any fire suppressants in that space. You don't have to have any power feed into that space other than what you might for a normal office or storeroom. So you're ripping those costs out as well and replacing them with just refurbishing or repurposing the space. And then we talk about cabling, the reduction in cabling. I did a design exercise about 6 months ago where we were looking at 16 data points in every room and a corridor that had around about 32 rooms in it. Now, it's not hard to start realizing that that main trunking that's going down the corridor suddenly has 32 times 16. So you're talking hundreds and hundreds of copper cables. Yet each one of those, from a PON perspective, can be serviced by one fiber. And in fact, if you ran a multi-fiber strand cable down that corridor and you're peeling off your fiber, so say you've got a 32 fiber cable, one cable is going to do what hundreds of copper cables used to do. So the type of structured cable management that you have to put into the buildings reduces dramatically. The weight of it, the size of it, you're suddenly freeing up space in that space above the corridors. Let's go on to the next slide, Gunter. So let's have a look at it. I mean, this is traditional copper, right? You've got massive cable looms in there. I've done this. I've pulled this stuff. It's horrible. It's dirty. It's just not nice at all. Let's roll through them, Gunter. Might as well go through it. When you've gone into fiber, you're just transferring, you're moving from those massive bundles of cable to these little bundles of cable. Really, not very much at all. And the size difference between a fiber cable and a copper cable, well, basically a fiber cable with multiple strands in it is almost the same size as a single copper cable. There's almost no comparison. And again, we're seeing this is what you're looking at with the fiber splitter boxes that Andy was talking about. They're just little cabinets. And these things can be actually tucked away in hidden recesses and walls. They can go up into ceiling panels that drop down. You don't need these rooms anymore. You just need these little cabinets, and they're secure and just tidy. Some other little aspects here, because you've got less of these building spaces. You don't need to have the problem with flammable materials, which you do get from cables. Deployment is actually quite fast because generally you manufacture these cables pre-terminated at the factory, and then you go to site with them, and then you pull them through, you blow them through to tubing, and then that's it, it's done. There's no more termination to be done. It's plug and play. Unlike copper cabling, of course, which you have to drag through, then you have to terminate both ends and you have to put them in. Let's go on. So then we're into OPEX. And one of the things I think about with OPEX savings is the total ownership, cost of ownership here isn't just about, can we reduce our procurement and our implementation, and what's the cost of the operating, which we can reduce, but also the cost of not operating. And I'll get to that sort of at the end. So reductions in OPEX, some pretty obvious ones. We don't have these IT hub rooms anymore, these IT secondary equipment rooms. So we're not powering them. Design exercise I did a couple of years ago for a mid-sized hospital basically reflected that just that saving, no air conditioning and no switches in these rooms would save around about £115,000 of OPEX per annum. So that gives you an idea of just the savings. Don't have these rooms, you don't have the same costs. You've got a reduced amount of network equipment to manage. Now, having been a network administrator and network manager, I understand what that's like. But rather than having to send guys off to various different parts of the campus to look at physical port problems, you're only going down to the one main equipment room, your server room, your comms room, where the switches are, the OLTs. You may have to go to the site or to the office to look at a network interface card on the PC that might be not working properly, but you're not going to have to go to site just to look at switches. You're not going to have to go to different little hub rooms and try and track it down. Everything is collapsed down into that main equipment room. So the amount of network administration reduces. These OLTs replace hundreds, if not thousands, of network switches. So there's another aspect, which is the management of those switches, the firmware upgrades, the service packs, the security packs, and all that type of stuff that you have to throw out to them. You don't have to do this en masse. You're actually just focusing on a handful of devices. So that's a reduction there in your personnel costs for managing the network. You're not going to reduce your staff numbers, but you'll be able to focus them more on the really important bit, which is keeping this network humming from a logical perspective rather than just a physical perspective. And then there's got the downtime costs that I mentioned earlier. When you are pulling cables from one end of a corridor all the way down that 90-meter stretch to the far end to put in one data point, you're disrupting everybody that's in between. I work a lot with hospitals, and that's a major impact because when you're opening up ceiling spaces, you're opening up dust and all kinds of mess, and you really have to shut down things. And just to refurbish a room can mean potentially shutting down a ward for days, if not longer. And that's a massive cost. That's a massive impact on any organization, let alone a hospital. With fiber, you don't have to do that because you've got your splitters at the other end. You've got your ONTs. Maybe you have to go from 8 ports to 12 ports in that room. You swap the ONT. Easy, done. You've not impacted on anybody. You've not shut down anything else. You're able to just go very, very smoothly and do that implementation with minimum impact on the organization, minimum impact on downtime, and that means minimum impact on their revenue. Let's move on. Following on from that, it's highly, highly flexible. So again, this whole business, if you want to reconfigure a room with copper, you have got to drag cables all over the place to get to it, and it's a mess and it's a lot of work. With fiber, it's a lot more flexible. It's a lot easier to peel off some fibers from your multi-fiber cable, do another fiber splitter box if necessary, do ONTs. It's very fast, very quick, and very easy to implement your moves, adds, and changes, as we call them, your reconfigurations of spaces. And that flexibility also goes into its longevity, how long you can work with this. I pulled fiber cables 30 years ago in places, and although I don't think the places exist anymore, if they did, the cable would too, and that cable will still be good. If you know about copper, you know that copper changes every 10 years on average. So we've had Cat 3. I don't know what happened to Cat 4, but then we jumped to Cat 5 and went through a couple of Cat 6s, and now we're into Cat 7s. There'll be a Cat 8 and a Cat 9. And a couple of things happen with every one of these iterations. Yes, the bandwidth increases. So we're going up 10 megabits, 100 megabits, gigs. But you also get thicker cables and you get shorter cable runs. So when you get into things like Cat 7, you're not really getting your 90 meter if you're wanting to actually do that type of length anymore, if you want the high speeds. And your bend radius is reducing dramatically. And that's the amount that you can actually bend a cable. Fiber can sort of bend like that. It's just really, really tight bends in them now. And they if you use armored cable, you're impervious to breakage. So the life expectancy in fiber compared to the life expectancy in copper is really, really quite dramatic. you're putting in copper now, but in 10, 20 years' time, it's going to be dropping off in its usefulness. You put in fiber now, and in 30 years' time or 40 years' time, that fiber cable will still be perfectly okay. You may have to change the end devices. They will change over time, of course. Moore's law still rules. Everything increases in power and capacity and halves in size and cost every year. But you'll be able to use exactly the same infrastructure rather than having to rip out the existing copper cabling and put in a new form of copper cabling. We don't talk about putting in Cat5 anymore. And in fact, wherever we see it, we say, get rid of it. It's no good. Same with Cat3. So the future proofing and flexibility in fiber is enormous. And then we get into the performance side of things. And Andy touched on it earlier, terabit speeds or 100 terabit speeds. Have been universities that have been doing testing on this, and they've gone into the terabit speed bandwidths. It's going to happen. It'll just take time for the end devices to catch up. It's not the copper. It's not the fiber cable that's not going to get there. It's the end devices that'll drag it down. And the equipment that you're looking at here, when you see those lovely big chassis and things, they are super robust. This is not new technology. It's new technology in the enterprise, but it's old technology in the telco space. It's been around a long time. So long, BT invented this stuff back in the late 80s. It's not new concepts. It's been around for a very, very long time. It's been powering the broadband world. It powers the mobile world. It's what isn't behind there. It's now just entering into the enterprise world. So this equipment is highly robust. I think, Gunter, your stuff is 5 nines, right? In resiliency. So the chances of a failure on the OLTs is phenomenally small. And of course, if you're designing right, you're going to have something like a 2 to something split. You're going to have redundant routes. If you're designing hospitals, and you're going to have multiple active passive type OLTs and partnerships. You're going to make it literally bomb proof. And it's just not going to break down. If it does, it's going to be such a rare event. It's super robust, super resilient. And here's a really nice little slide that I'm going to finish off on, which does show this comparison between the bundles of cables versus modern single mode fiber cable. So on the left-hand side, we've got 2 types there. We've got our multi-mode fiber cables, and we've got copper, in this particular instance, Cat5 cables. Now, that's actually quite important to note that Cat6 is thicker than Cat5, Cat7 is thicker than Cat6. So if this was a photograph of Cat6 in there, that bundle would be a bit bigger, actually. Those cables there are represented by the fiber cables on the right-hand side. Imagine that's that.
Not even close.
Yeah, imagine that in your ceiling space. And it really does play into what Andy was talking about with the old hotel, because a lot of our buildings in the UK are old, and you have all kinds of problems on actually punching holes through them and sending more cables through. Simply by removing some of these copper cables, you've got big access routes already for your fibers to go through. And in the middle, it's green. You don't have any copper. You're reducing the amount of power you have as far as consumption. If you are out to achieve sort of net zero targets, which if you're working for a government organization, you've got to be looking at doing that these days. This is the technology running forward. It's green. It's green friendly. It is simply the way to go in my mind. And that, I think, can wrap it for me.
All right. Thank you so much, Kevin. Really appreciate it. I think, myself and the audience learned a lot about your perspective as an evangelist, as you said, but knowing the technology for a long time, knowing traditional LAN technology, what we all grew up with for a long time as well. I think one of the interesting aspects you brought up is also not just the reduction in space, reduction in CapEx, on the OpEx side, the downtime cost, what dramatically is being reduced. So really interesting update. Thanks so much. I know we have probably just 10 minutes left, but we have some time here for Ian. from Connectix still to give us a glimpse where we can learn more about passive optical networks. So Ian, over to you, and then we have a few more minutes still for a quick Q&A.
Okay, thanks, Gunther. I'll try and keep this brief to allow us some time for Q&A at the end. So my name is Ian Irving. I'm the sales director at Connectix. Connectix is one of the UK's leading suppliers of all that copper cabling that the guys have mentioned, Cat4, 5E, 6, 6A, etc. Our heads were turned towards PON as we entered into the broadband market sector, supplying service providers with this technology. And it begs the question, why don't we see this more in the enterprise? So one of those factors, after listening to some compelling statements put forward by the guys, was lack of awareness and education. To that end, Connectix offers training courses. All of this information, I hasten to add, is available on our website, so please take time to visit it. But I just want to highlight two of the many courses we offer focused on PON technology. So the first one is a PON theory training course, which is done via Microsoft Teams. So it's a 3-hour overview, a lot more detailed than obviously we're able to go into today, but it's for designers, consultants, etc., to give them a better appreciation of some of the factors that you need to consider when designing a PON network, the industry standards, installation techniques, and comparisons to traditional structured cabling, so you've got some sort of comparison between the two. The next course we offer, you can just flick through, Gunther.
Yeah.
So this is a practical training course, and this is more focused on engineers. So it's the guys who actually go out and install the product, but to give them a greater appreciation of not just how to install it, but the theory behind it, how PON works, factoring in things such as dB loss budget ratio into the design of a system, and why you do the things that you do, where you place the splitters, and how the fiber interacts right the way through from one device to the very end device. So the course itself obviously requires quintessential fiber skills. So this isn't, we do a separate course on the basics of fiber termination, polishing, testing, etc. You need to have all those credentials to attend this course, because we're not there to teach you how to polish and splice fiber. We expect you to have all those basic benefits. But the course then provides you all those opportunities to plan ahead from an engineering point of view. Okay, so that's pretty much all of our training. As a business, as I say, Connectix has entered into a partnership with DZS on the back of on the broadband market sector. But it's the enterprise sector that really excites us. And I was left quite a number of years ago asking the same question: what is the catch with this stuff? And after listening to the guys speak today, hopefully you found the same question at the end of all this. And with such, I'll hand over to Gunther, and we can go through hopefully some of those questions.
Yeah, thank you so much. I know we have a in the Q&A. We have one. Andy, do you see the Q&A in the Q&A question already? Have a look. I think in the meantime, I'd like to ask Ian. You know better than anyone also the cost between copper and fiber. Can you give us a bit your perspective on that? How did that change over the last years?
Yeah, well, going back to the days of Cat4, Cat5, the copper market was always looking over the horizon and saying, right, we've reached the end of our tether, fiber will appear and dominate. And the biggest hurdle in that was the cost. Over the last few years, that's changing quite dramatically into the fact that the two are crossing now. And if you look at the automobile industry, so you've got the boom of electric vehicles now. And if you take a typical electric vehicle, it contains 4 times the amount of copper than the equivalent petrol or diesel vehicle. So that in itself will put a greater demand on the copper that exists. It's becoming a valuable commodity, and forecasters in that sector are now predicting of not just 20%, 50% increases over the coming years, but the cost of copper doubling. So that in itself is quite a factor just on a pounds and pence perspective.
Okay, that's interesting. And then Andy, I know there are a lot of questions about you can run multiple VLANs on a single port. How does that work for passive optical LAN networks?
Yeah, it's a really common question, Gunter. We have, of course, now with the enterprise, you may have a single port with an IP phone and then a PC behind it. So you need two separate VLANs for that. And the answer is we support all of that. We support multiple VLANs per port, different VLANs on different ports. We can send it's technical list, but we can send the VLAN tag forward, or we can strip it off. We can change it if you want to. We do all of those enterprise features with VLAN. Gunter, I don't know if you can see in your chat. I don't know if you can
I
see the chat
cannot,
there.
but you can see it. So if you want to just bring up the question, please go ahead.
Yeah, so the first one was really about the cables that Kevin
see.
showed. It suggested the 144 multi-mode cables. What core count does that picture represent? As you could get single cable 144 core multi-mode fibers. So I suppose the question was really I suppose the answer is that it's not necessarily about the picture on the left that we saw, which was Cat5 and multi-mode cables together, but more pointing out that the picture on the right was single mode cable where the footprint's far smaller. Right, Kevin?
Yeah, and I guess it's an important thing to point out that in general, POLAN runs on single mode fiber cable. It can run on multi-mode, but you require adapters on the end. So if you had an existing infrastructure, you could still leverage that existing infrastructure of multi-mode. But now you don't do multi-mode, you do single mode cable.
Yeah. Yeah, indeed. I have another one, actually, probably for you again, Kevin, actually. Why do you think the consultants are designing structured cabling solutions for end users and not suggesting PON network as part of a new fit out? What's your experience with the consultant?
I would say that's primarily down to a lack of awareness of the technology as an option, rather than anything else. A lot of the network design is driven by the big network companies. So you're talking about Cisco, Extreme, Blade, Juniper, those guys, and HP, Aruba, can't forget them. And almost to a T, none of them have fiber except Cisco. Now, so if they don't have fiber, these guys are not going to promote any fiber solutions. And so most people won't really be aware of it. I happen to have encountered this about 7 years ago. I was lucky enough to talk to guys from Huawei. Yes, I know it's a bad to use, but they are a leading proponent of fiber and POLAN, and in China, they are doing POLAN everywhere. All their government buildings are going POLAN now, and it was really interesting. It was really eye-opening, but I didn't even know. But I didn't even know that Huawei did servers and all that type of stuff, and they do. So for me, it was eye-opening. It was an awareness thing, and suddenly I realized there was this technology that I hadn't really seen before coming to the fore. And I think that's what has happened now. The interesting thing is Cisco originally didn't have any stuff. Then they had GPON for WANs. And then they started bringing in domestic sort of level POLAN devices, and now getting into small enterprise. So they are changing. They are starting to pick this up, but they're a slow mover. But for me, the writing is on the wall. If Cisco are now picking up on something, it's going to be a trend. It's going to become evident in the future. So while as they become more vocal about it, watch the space over the next few years, the awareness will grow. But that's the whole point of these type of webinars from DZS, is to actually push out this awareness, get it out to people, say, hey, there is a technology, it's a new kid on the block, kind of a new kid, it's been around for a while, but it's going to change the way we play the game over the next
I think, Kevin, to your point, I think it is really just the awareness. I think a lot of consultants are just not aware about the capabilities, the technology, and all the advantages what this networking technology can bring to their use cases, right? And so that's one of the reasons why we have this webinar series. It's not just a one and off. We do see a dramatic opportunity literally in the UK. You were talking about the hospital environment. We see it with stadiums. We see it with hotels. So various industries are right now in the process of obviously picking up the technology. And it's sessions like that help us to just communicate what is actually possible, what technology we have today available, and we want to spread the word. So ultimately, we are here to just expand the community of advocates. And I don't know if some people of you were earlier on. Ian was asking, shall we share that we want to host, obviously, a networking event where we want to bring people together, and that will happen in the fall. Because we know a lot of people are going on vacations during July and August, but in fall we'll bring people together in London, and we continue these conversations. But I think there are probably a couple more questions on there.
Yeah, definitely. So yeah, one of the questions is probably for you, Gunter, and for Ian actually. There's keen to understand the market capability and capacity to install this. To deliver and install optical LAN at scale in various different countries. How do we intend to handle that side of things?
Well, it's obviously a combination between Ian and myself. I mean, it's partners. It's a partnership. Company like DZS or DZS, as you say in the UK. We have we have obviously we have guys like Andy who are out there in the field and are hands-on and have done it before. And we have obviously the Connectix team. And I let you, Ian, to jump in here because there's a reason why you offer trainings. There's a reason why you're such an advocate. We have other partners like MLR and others in the country that are actively involved with projects.
Absolutely. I would say it's in its infancy, and that's something we definitely need to grow for a competitive environment. And again, it comes down to awareness. We've got two aspects of this as the passive infrastructure design, which, to be fair, the skill set already exists. It's installing fiber, terminating, polishing it, albeit on a splitter, etc. And then there's the actual implementation of the full network, utilizing the OLTs and the ONTs, knowing how to configure that. And that's where the DZS side comes into it. So we're looking at a full solution, combining the passive and active infrastructure in a PON network. So with Andy's assistance and some of the team at DZS, we've put together a training course, and there's 3 steps on that to becoming a fully fledged partner at the top level. So there's 3 different methods of going through that and acquiring the necessary skill set, so you can set up your NOC with your own OLTs and ONTs and go out there, demonstrate, configure and install the equipment. And indeed, if you'd asked me 3 years ago, well, who's installing this stuff in the UK? There is not many. But over the last couple of years, we've started to see more and more installations. We've just finished 2 major installs with a partner in London, which we can hopefully use as a reference site once we get permission. So it's just increasing that overall awareness. And we're encouraging our existing structured cabling partners who are already proficient in the fiber aspect. We've been eulogizing all the virtues of PON to them. We've had a fantastic response and interest. So we've got people signing up for those courses, and we expect to, over the next 6 to 12 months, see an expansion of the qualified partners able to implement PON solutions in the marketplace.
Yeah. Alrighty, I know.
Just one more question.
Go ahead. Okay,
one,
let's go.
One more final question before people drop off. It's from my old friend Matt. Hello, Matt. How are you doing? he's asked if you were to pick one sector that you think will adopt GPON for enterprise before others, which would it be and why?
Well, I give you my answer. What we see across the board, it's not just in the UK. We see it in Europe, particularly southern part of Europe and Germany. We see it in the US, where I'm based. That hospitality, all the way to Latin America, hospitality has been taking advantage. Some of the premier hospital, luxury hotels, they have been deploying it for the last years. We see it and I'm sorry, it's not just one sector anymore. It's the hospitality space, which is big behind it. We do see it mission critical environments in the hospital environment, because as Andy pointed out, there is a lot of bandwidth requirement for some of the data transfer. And then obviously it's a lot of times it's not just the fiber termination, it's then where you use then Wi-Fi 6, Wi-Fi 7 also capabilities right from there from a wireless perspective. So we see stadiums, we do see the entire entertainment space, and we see just in general, it's the smart office, new offices being built. They are much more interested in a green type of net zero carbon emission kind of goals, meeting those goals and KPIs. And so I wish I could say it's just one specific. We know that hospitality sector was the driving force, and we see a lot more in that space. And but we see it now across the board in so many other industries. So, yeah. But I know a lot of us enthusiastic about it. I think Kevin, said it very candidly that it is all about awareness. And this technology is proven. This technology is proven to manage not just the subscribers in millions with the service provider community. It is literally, also making all the inroads right now in the enterprise space, and particularly the smart enterprises, that the CIOs and CTIOs that are forward thinking, and they say, look, just because we have done something for the last 20 years or 25 years doesn't mean this is the use case for continuing with this traditional LAN technology. And I think on that premise, we are going to continue this webinar series on that topic. This is not a one-off. We're also going to host a session in fall in London. And I'm inviting everyone already. Watch out for the invites. We will extend an invitation to you. And please, wherever you are across the UK, make the trip to London, and we'll find a nice venue where we can meet up and continue this exciting dialogue. So with that, I want to thank my panelists, starting from Andy to Kevin and to Ian. I want to thank Taylor in the background for making it all happen. And with that, bye for now. Thanks so much, everyone.
Thank you.
Cheers.